Okay, hello, everything is great. So let's start our drivers DSA sheet. कल हमने कहाँ छोड़ी थी? आई थिंक we were on count inversion problem. We have done this reverse pair problem and maximum product subarray. So we have to do the reverse pairs. I have done it. Let me take the summation, runtime error, and this. It is optimal? Not. Yes, it is quite optimal. Okay. The main logic is we have to reverse the pairs. How we have to, like, given an integer array nums, return the numbers of reverse pair. Reverse pair is that, like, okay. So we have to count how many pairs are such that if A is B, A, like, index of A is smaller than index of B, and A is greater than 2 times of B. How many such pair exist in this array? We have to find out this. It has only one most, like, optimal way to do this is merge sort, because, like, one way is order of n square brute force. We have to check either all the pairs and just counting the space, but the time constraint are 10 to the power 4. 10 to the power 4 merge sort will like, n square might be acceptable, maybe acceptable, because 10 to the power 8, or maybe time limit exceeds. We can solve this from n square to n log n by the merge sort. The idea of merge sort here is because there is a listen, like, in merge sort, what we are doing is, first we dividing the larger interval into smaller interval. Okay, as we divide into 2 smaller interval, at the process of combining time, okay, at the time of combining, we have the left and we have the right, and their order at the point of combining. For example, I am at merge procedure, I got A and B. The relative order between A to B will be exact same, will be the num. For example, if this nums is divided into like 1 3 2 and is divided into 3 1, like, we have sorted this part, the relative order inside these sub problem will be changed. Okay, I know it will be changed. But if we are talking about element taking from A and another element that is picking from second array, their relative order will always be according to this original array. That this is the pick, and other pick is, if it is sorted, we have to find a one index where condition is not satisfying, and at that point we will know that definitely we will know, like, definitely the answer will not exist for beyond that index. Beyond that index there will not any element. For example, let's take A comma B, and A is greater than 2 star B. Okay, now there is an index 1 2 3 4 5 6. Okay, now we have an element A and we are creating an element B. If A is greater than 2 star B, if here an element occurred, like, we will take A element from the first array and we will choose B from the second array, and we will pass the condition A, that is greater than 2 star B. Now we will get the certain B such that this condition will no more satisfying. Then we will know that all the elements that are right to that B will also not satisfy that condition, so we can terminate our that searching operation for a particular A. Let me solve to you. For example, we have 1 2 3 and we have 1 3. We just want to compare. We will select first, we will select 1. We will select 1. Okay, we will compare this 1 to this. We 1 as A and this one from B. Okay, we'll check the condition. If 1 is greater than 2 star 1, here the condition will not satisfy. The condition is not satisfying. Okay, the condition is not satisfying means all the element beyond 3 will be greater than this one, and as this one itself is not satisfying the value, then the element that are greater than this will also be they also will not satisfy the condition. For example, here 1, it is not satisfying the this one. It is like if an element A, if 1 is kind of less than just forget about this 2. Think this as like if A is smaller than this 1. Okay, now A will also smaller than all the elements that are greater than this 1. Okay, you know that. Now just add the 2 here. Let me that is why we are choosing the merge sort here. Okay, we have to int result. If we are declaring result as class object member variable, then we need to find it and just return this result. We are in merge sort, we have to define 2 functions, and that is one is recursion and another one is merge procedure. So we are going to define the merge sort. Okay, merge sort will take int I comma int j comma vector of int address of nums. Okay, if I is greater than equals to j, return, else we will find the middle value, that is I plus j minus I divided by 2, and then we are going to merge, we are recursively destroy the array I comma mid comma nums, and we are going for mid plus 1 comma j comma nums, and there will be merge procedure that will combine I comma mid comma j and this nums. The main part will be in this merge. We have void, we have merge, we have integer L, integer mid, and integer R, and vector of int address of nums. We have to make 2 arrays, that is int n1. The length of n1 will be mid minus L, 1 2 3 4 5 minus, we have 1 or 5 plus 1 divided by 2 6 3 0 1 2 3, so 3 minus 0, we have 3. How many elements do we have here is 3 minus 1 plus 1 and 5 minus 3 2. Okay, that is mid minus L plus 1 element are there, and int n2, the elements in right array will be kind of R minus mid. We have to make the 2 vector of int, that will be the left for n1 and another will be the right for n2 size. Now we have to initialize the element in this for int I 0, I is less than n1 and I plus plus. So left of I, that will be nums of I plus L. I think L, not L, I plus L. Okay, the last element that is going to store in this left will be, just put a mid minus L here. The last value of I will be mid minus L, and that will be mid. Got it, everything is work fine. Now we have to initialize the writer array. It will go for n2, and we have to initialize the right of I will be nums of, that will be mid plus I plus 1. Okay, we have initialized the things, and now we have to combine the things. Okay, we have to combine those every kind of. So for combination, like we have int k equals to 0, while we have to define int I int L L1, that is 0, R1, that is 0. Okay, while L1 is less than N1 and R1 is less than N2. Okay, so if we have the nums of, not nums of, if we have left of L1 is lesser than equals to right of R1, so just add nums of I plus k will be, I plus k will be left of L1 plus plus, as there will be right of R1 plus plus. In the both cases increase the value of k, and while L1 is less than N1, we have to do this, that is here should be L, not I. Okay, k plus plus, same for while R1 is less than N2, I should have to remaining and k plus plus. Got it. Now here we have sorted and we have merged both arrays. Okay, arrays both merge हो चुके हैं. अब we have to apply, now we have to we have already divided the array into two parts. Now for each part, and both of the part are sorted, like we do have 1 2 3 and we have 3 comma 1. So whenever we are going for value 1, just count how many values are there. Okay, so 3 1, I have just make the 3 1 for 1 it is greater than how many it is 1 3. So I have to find this one should be greater than 2 star a. Okay, so I have to find the value of what should I have to find is, I'll take the value a from first array and I'll take the value of b. I have to find that a is greater than 2 star or not, a is greater than 2 star or not, 2 star b or not. So we can use the binary search or we can use the normal linear search for every value in L1. Just check how many values this condition is satisfying. Okay, just first of all we are applying just simple, we have already processed 3 1, So for every value of I, just think so we have to initialize the right array first, and we will do our task in this array as well. I have to do in sorted. After sorting I have to do this. No, this and this are already sorted, and I have already counted for 3 1. We have 3 1, we have 1 3 here, and we will have 1 2 3 here. So I will take for every element in 1. I'm checking. Okay, no, I go for 2. I'm checking for, okay, 2 is greater than, no, 3 is greater than 2 star 1, yes. Okay, so I have to initialize this. Okay, I am going to initialize this, the right one first. No, I am going to initialize the right one first. On the time of initialization this value, I'll check like for int x will be 0 while x is less than n2 and n, like right of x 2 star right of x for left of I is greater than 2 star right of x. I'll just updating the x plus plus, so x will end up some variable. X will end up with 0, so I'll add result plus equals to x there, and let us see it will work or not. Merge sort, and we are going to add 0 comma nums dot size comma nums. There is a runtime error. I is greater than equals to j, then return. I don't know why there is an error. If I'll j minus 1, not j minus 1, it will j minus I. Accepted. Let us see this runtime error object. If it work, then it will work. Run signed integer overflow. Signed integer overflow, that will appear here. Signed integer overflow. Two star right of I. Heap buffer overflow. Okay, x is less than n2. I am traversing on right side array, not left side array. So this is my fault. And I got penalty for this one wrong submission. I think I will not get time limit exceed. I'm getting the time limit exceed. Why I'm getting this time limit exceed? Due to this extra while loop. Okay, so we can remove this by using merge sort, I think. Okay, there is a time limit exceed error. Like just check 1 2 3 4 5 6. We have to do the 1 2 3. We have 1 3. We have this 3. 3 is greater than 2a. 3 divided by 2, that is 1. Find the lower bound of this. What if we have 2 here? 2 divided by 2, that will be 1. Upper bound of 1 not present there. We will get 3. And we have to divide by 3 divided by 2. And we'll get the 1. For binary search, we have to think about 1 2 3 and 1 3. As we are 3, so 3 divided by 2, that is 1, and 2 divided by 2, that is also 1. So we have to find the value that is greater than 1. Okay, if we got the value of 2, for this 3 is 3 is greater than 2 star x. X would be less than 3 by 2. Okay, just process the right array first. Command X, just process the right array first. Left array, we are processing left array first, and on the right array we are just making the 3 to the 6. So we have to find auto. It will be upper bound of right of I, 2 star right of I, in left dot begin comma left dot, and we will get the lower router bound, and I will get the result will be plus equals to like 6. 1 2 3 4. If it upper bound is there, begin is there, 1 and 2, and that will be left dot and minus it. I think it should work. Sign integer overflow. uh, okay, if 2 star I is greater than like it is exceeding the integer limit, then it will obvious, we will not find that value inside that. Okay, so if 2 star or I right of I is greater than int max long. Why and compilation error. It took me around how much time? 26 minutes. Just got some different answer, why I don't know. For every element of this right I am just adding I don't know what's the problem now. A should be greater than 3 raised to power 5. A should be greater than 3. There is not an equality, so upper bound will ensure there should be not an equality. Okay, it is working fine. Where is the test cases? and test results. It is working fine for all the layer. It is not working for this. I think some kind of it is quite low. It is quite low. Why it is low? Does negative value are doing something? Let me check. I is greater than equal to 0, we will return it. I'll j minus I divide by 2, and I'll go for I on mid plus minus joe, and then we will merge here. It is perfect fine. I'm just calculating n1, that is, I think problem is in this. Its k is 0. L1 and R1, L1 is less than N1 and R1 is less than N2. Left of L1 should be less than equal to right of R1. Then nums of L plus K will be equals to R left L plus plus. Else num of L plus K will be equal to right R plus plus. Okay, and we are going to fix K plus plus. Everything will happen while L1 is less than N1. Num of L plus K will be left of L1 plus plus, and while R1 L1 nums of L plus K will be R1 plus plus. The merging is correct. Merging is fine. L1 R1. Left of N1 size and N2 size, I0 N1. Right of I, mid of I plus 1, absolute of long. While it is just not adding some things. What could be the things? Like my condition could be wrong. It is int max if 2 star I, if less than equals to int max, then only we are going to for absolute of star I is going to be 2 star right of I. Okay, if it is lesser than, because the element in this are in the range of int max, this element or all the element are in the range of okay, I think no. If long of I is less than no, that will, it should be beyond the range. I don't know why it is not working. Let me check the solution, my previously accepted solution. Just see here. I'm just like I have just, I don't know why it is, but I just write the same code, and still I here I'm not checking the long and integer max condition. Still I'm not able to figure out. There's a like listen, 2 raised to power 31, I think it is the 2 raised to power 31 minus 1. And minus 2 raised to power 31, nums of I will be this. The value should be smaller than this or smaller than this. Int max. Left dot end minus it, the exactly same thing that I am doing here, the exactly same thing I'm doing here, the exactly same thing I'm doing here, but I don't know. K is L, K plus L, whatever you do. L is not changing here throughout the code. See the test result, it is giving int max 2 star I. 2 star I should be long 2 star I. What's the problem? I don't know what's the problem. Let me check with GPT. It is giving the TLE. I have done this before. It give me the time limit exceed error, bro. What are you doing? Oh, let me just do the same code that I here we have accepted code. I'm just copying it and I'm just pasting it here. Let's check it is working or not. It is working. It is working fine. Means something is wrong in my code. Result 0, result we have 0 nums. We have assigned the result 0 in this result, okay, before calling this merge. And we have num result nums 0, num dot size, it doesn't need even this. Merge sort I plus j minus I divided by 2 I mid nums mid plus 1. Let me check the sorted array pure. This is correct. I have to check. N1 mid minus L plus 1 and 2 R minus mid. N1 mid minus L plus 1 and 2 R minus mid. Vector of int left 1 and 2 N1 and N2. Vector of int, array yaar, I have decided here long. See this long. If I am going to decide here long, it will take extra complexity. So I need not to describe this condition here, and right is already this. See, that is not the part why I am just doing for long here. I am just giving extra 4 bytes for each element corresponding to the each element. Listen, if 2 star right, it is exceeding integer max limit, means none of the value in the left side will be bigger than that value, because the value on the left side are all smaller than int max, okay, and 2 star I is bigger than int max, or we know that the value on the left side can never exceed the int max. It will be within the int max. So why it's happening? Just think. If 2 star I is if 2 star right of I exceeding the value of int max, so we need not to check for that particular value. If 2 star right, if long of 2 star right, okay, if long of 2 star right is an int max and int min, okay, there might be an issue for the contribution of that value will be 0, not 0. I am not able to understand if 2 star right of I is greater than int min, it is just the value of right I, 2 star right I, it's just exceeding the maximum value of integer. It's just exceeding the maximum value of integer. Then how it is possible? How it is possible then the value from the left side will be greater than 2 star of I? That is means to satisfy this condition, we must have the value on the left side also bigger than the int max value. And int max value, a value that is greater than int max value, cannot be contained by this int data type. Two raised to power 31 and 31. Let me see the nums int min and int max values. That's it. See the difference? Int max is this and int min is this. Exactly, we have this is int max and this is int min. Okay, this is int max and this is int min, and I am saying that if 2 star right of I is going beyond the int max, it is going beyond the int max, then is there, it's like the value that is greater than that value will never exist on the left part, so the contribution will be 0. So I am not able to, yaar. I have to solve this with an int. Okay, okay, it will use the concepts. I am not able to understand. I am getting this int left or right. Just 2 star right value. This 2 star right of it is going beyond the. It's going beyond the integer value, and there is a value that is greater than 2 star right is not possible, so it will not contribute into the answer. So this is logically correct, but why not? What is, I'm just taking this long I. Okay, it should be lesser than int max, and then long this value, whatever the stuff it is, it should be greater than int min. If it is possible, then we are able to solve this, otherwise we are not. Here we are getting wrong answer. Why? Long to search, that is 2 star right of I, that is long value to search. Oh God, I understood the problem. Okay. Okay. I got it. For positive number it doesn't exist, but for negative number it do exist. It can exist because the negative number, if we take the twice of a negative number, the number will become more negative, and there can be exist a greater value than any infinite negative. 0 is greater than infinite negative, still the infinite negative is beyond the range of integer. It's still great, smaller than 0. Okay, that is why it is happening. Now I know. Okay, got it. Something new. I just found something new. Optimal complexity, the complexities of optimal solution for this reverse pair is only complexities. Let's just see the complexities for optimal solution. And log and time complexity and space complexity. Okay, though our solution is optimal, we can't further optimize it. There is a maximum product summary. Okay, let's start with this, and then we have binary search, the next topic, that is 31. Binary search. Maximum product subarray. Given integer array, find a subarray that has the largest product. We have to find the subarray, the product of its element should be largest, return the product, and the test case are generated that will fill. Okay, note that the product of any array will be single product of array. Okay, we have to find the elements, we have to find the largest maximum product subarray. If all the numbers are positive, if all the numbers are negative, there is a two cases. If all the numbers are positive, and for positive number we need not to worry about. The concerning thing is either the number is negative or it is 0. Either it is 0 or negative. In case of 0, we can't overlap the interval on the left side of 0 and the interval on the right side. We can't merge, because as in any subarray 0 appears, the element will be 0. So we'll count for 0, that there is a 0 0 0 0. Whenever appears 0, we have to reset our product subarray to 1. Okay, like we have an array. Okay, now there is kind of some 0. As the 0 appears, our problem will divide it into sub problems. Either I'll get this answer from this, or this part, or this part. So 0 is quite it's make our task easy, because as 0 occurs, it will divide our problem. So we can recursively go for this part and this part and this part and this part. Okay, now for a particular part, if the element is not 0, if all the elements are positive, it will return the product of all the element. Now difference is negative numbers. If there are even number of negative number, then we need not to worry about, just product, and product will become positive. The main thing, we can't rearrange the elements, because their relative in subarrays relative order should be maintained. So the problem with odd, main problem with odd, negative integers. So it's like, we have 9 8 minus 7 2 4 minus 5 1 1 1 1. So we have here odd number of negative integers. So what we have to do is, we have to find some way, this negative number, this negative number, and this negative number. So अगर odd negative number है, if we have to odd negative number, so आपको किसी भी एक एंड का नेगेटिव नंबर को सेक्रीफाइस करना पड़ेगा. either combine this one, or your answer will be this one. मैं बीच वाले एलिमेंट को अगर मैं करता हूँ, तो मेरा जो प्रोडक्ट आएगा, that will be not efficient. If you get the odd number of negative number, like in this case I have this thing, so either you sacrifice the left side negative or right side negative. Like we have multiple negative number, because we know that okay, so first count 0. As soon we get the 0, just do the divide the sub problems as we get. Okay, let's start with our approach. I have to create a function, and I have to mark int function. It will take int left, int right, comma, vector of int, address of nums. Okay, now we have to find the int n, that is nums dot size. We have to find for int I equal to 0, I is less than n and I plus plus, and int previous non-zero, that is 0. Okay, as we encountered with 0, if nums of, we have to change the int maximum, we will going to return that maximum. If we are getting any nums of I that is equal to 0, we can say that it is not present, then I have to got the maximum will be maximum of this function I got 0 here. Okay, in the brief there will be I plus 1, and I got this 0. At the index I'll get the 0, and here we have the previous comma I minus 1 comma nums. Let's say we got the 0 at first index 0, then we are going for I plus 1 and the previous index. Okay, and the previous non-zero is, I don't know what about previous non-zero is. Let's say previous non-zero is minus 1. Previous non-zero is 0. Previous non-zero is minus 1. First loop, I got a non-zero value, store it. If it is not 0, like if L is equals to R, then we are going to return nums of L. Got it? Okay, if nums of I and prev is equal to minus 1, then we are storing to prev is equals to I. In such case I'll get the values of previous index. So I have previous, that is minus 1, 0. I'll call the function for minus 1 and minus 1, it will return the 0. So if L is less than 0 or R is less than 0, just return 0. Now if we get all the 0, if we get all 1, then we are saving previous, then 0, then okay, got it. 0 we got it, then 0, we are going for this. Okay, now 0 0 0. Now at the end of the array, we are not, IL will become to n minus 1. Either it is 0 because in the loop it will not call the final value 0 0 0. It will call the last value, it will terminate, does not calculate the value for this. We got the 0, we got it minus 1. Okay, got it. everything is crystal and clear. Now we have to find here the negative value and the positive value. Count the, okay, we have a long product counter. Nums of I will be 10 and 10. 10 into 10 raised to power 10 appear 3 times. Product will be 10 to power 3. 10 appears 5 times. Product will be 10 to power 5. और 10 appears 10 to power 4 times. 10 to power 10 to power 4. That will be, ये तो फाड़ देगा, ये तो बहुत बड़ा हुआ. मैं पूरा product of any sum, okay, product of any subarray of nums, any subarray is guaranteed to fit into 32-bit integer. Okay, so we need not to worry about this. Product of any not result, it's saying that subarray, so we can go for product, that is 1 4 int I की value L, I is less than equals to R, I plus plus product star equals to nums of I. Okay, now we have to find the first until we get the first. So 4 int I की value L, we have to count the negative values. Int C, that is 0. I am just brute forcing, it is brute force. I am just, for everything I am just use a counter or anything. If nums of I is less than 0, just C++, and we are going for like if C modulo 2 is equals to 0, that it is even number, then we are going to return product, or we can say that product is greater than 0. Int I value will be L, the value of I will be L, and int I will be L, or while L is less than equals to R, and it is only one integer, so I have to while nums of I is greater than 0, int pro, and I'm just pro star equals to nums of that I. I have odd number of, so I'll get up to this. It is not possible that I'll get the all now. So if it is on negative side, I have to do the kind of pro star equals to nums of I. Now I will be R, and while I is greater than equals to L, and then nums of I is greater than 0, do I minus minus, and after that pro 1, that is 1, pro 1 multiply equals to nums of I, and pro 1 multiply equals to nums of I. So we are going to return maximum from product divide by pro, or product divided by pro 1. Okay, go. It should work. We have 2 3, output is 4, expected is 6. Let us see how it is. 2 3 minus 2 4. This is not any kind of 0, so this will become, and my function will call for this. I'll call for 3 to the 6, 6 to the 12, and 12 4 the 48, minus 48. And if product is negative, I'll need not to count this. If my product is negative, if my product is greater than 0, then I'll just return the product. Then if my product is written, then either I will have to remove this part, or I'll have to remove this part. So let us see. I will L, pro will be 1, and I will be 1, while I is less than equals to R, and nums of I is greater than 0. I'll add in, and pro I'll multiply with I. So multiply with, here we will stop, and I am gonna multiply this nums of I. So this will be my I. Now I'm again creating a pro 1, that is 1. I'm getting R1, while I is greater than equals to L. I'm just nums of I is greater than equals to 0. I'll I minus, and I'll have to these stupid things I was doing. We don't require this. For negative number, I think it will work. Let us go for some kind of test cases, because we do not want the our submission to be wasted for this problem. It is not optimal, but it will work. The product of any subarray should be fit into this test case is invalid, babe. You are giving us an invalid test case. It is invalid. Who add this? If the constraint was not there to the test cases is not in this to integer, it will be, the solution will be, now I think it is simple because they added the extra constraint. Okay, fine. bool. I just forgot 0. It got accepted. It got accepted because they remove some constraint that make this question simple. Because if this constraint was not there, then I can't do these things I can't do, because I'm just producting the whole subarray. So we need to do some more, like I need to do some different approach, but they add this constraint, so this question will become too like kind of easy, because at the time of problem they have this constraint and we cannot solve this problem with this constraint and with this approach. For in this approach, the sub array or any sub array should not exceed the int max or long max. Kiden algorithm, we can't do this Kiden algorithm because subset. We have to find the optimal solution there for this test case. The test case is 0, this or this. For this test case we can hard code our solution. Such kind of test case, it is see 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 10 raised to power 19, that is 1e19. We have 1e9. Now let's go for, do not waste your time and let's go for, I don't think optimal solution इसका देखना चाहिए क्या. Complexity will be order of n. For this problem the complexity will be order of n. It is optimal, it is quite optimal. We are not using extra space, we are using extra space due to this function calling. If there are n zeros, then the function will call n times, and due to the call stack calling, the space will be order of 1, because it is not recursive call. Function will call and then function the whatever we call it, control will go back to that max. So the controller will be moving from there, then there, then there, then there. So the space complexity in this is order of 1 and the time complexity will be order of n. Okay, let's go further. Now we have binary search question. Binary search to find x in sorted array. So it is pretty simple question. You have to implement the binary search, which I have not implemented, so I need not to implement the binary search. Just find the main question are implementation of lower bound and upper bound. It is quite good question, you should do. If you are like, it will for lower bound and upper bound we also use the custom comparators. So it will basically clear the concepts how to use the custom comparators in upper bounds and lower bounds. So you should go with that question. So lower bound, GFG practice पर हुआ ये. Lower bound GFG practice. I think I have submitted it, not so. And we have upper bound and we have insert x position. Okay, so basically what are lower bound and upper bound? Lower bound, we have to find, for example we have 1 2 3 4 5 5 5 5 5 5 5 5 6 7 8 9. So the lower bound of 5 will be this element and the upper bound of 5 will be 6. Okay, in the lower bound we are getting the first element, that is not less than this element, the first element that is not less than target. Okay, for example in 1 2 3 4 6 7, in this case the first element that is not less than this target is this 6. Okay, and the upper bound, we are searching for the first element that is greater than that particular element, in this case is 6, in another case that also is 6. Okay, so upper bound mein if you got there, if you got the equal element, then you need to क्या बोलते हैं उसे, झांकने को. लेट अस सी. ओके, झांकना, to peeking. Okay, you have to add whenever you are standing at the particular element that is equals to target, you have to peek on the left side, that whether the element whether the current element is the first element that is not less than, like if when you peek to the left, if the element is equal to the current element, then you should move to the left. Okay, and you can do this by using binary search. Okay, this implementation is pretty simple. The main implementation is you have to understand how the custom comparator works. Okay, I think I'll not do the live, because in live we sometimes forget, like we are not able to memorize the topics. So in live we are like we have to read the article, some we have to memorize the whole things. Sometimes we in our mind the suitable examples are not coming, so that's why I'll create a video upon lower bound and upper bound. That will be the brilliant idea. So let's just implement this. It is quite simple. Binary search. Let us go for binary search. We have to define int lower, int l. Whenever you are going to solve the binary search question, for me, when I was doing binary search problems for the first time, I got many errors regarding the L, like whenever the condition are not meet. So there are two ways, either you are doing for L is mid +1 and R is mid -1. So there you will like when you solve the problems, then you also face the same problem. Using this, instead of this, you will get infinite loop. Then you come to know, rather than pushing this index, you should shrink the boundaries from right side. You will figure out when you solve the binary search problem from this diverse TP sheet as well. So let's implement int I, that is 0, int right lower bound it is 0, it is writer bound it is target dot size -1. Okay, so we have to run while L is less than R and return the if element is not present in the row on the length of array. Okay, if like L, if target of L is lesser than, like if array of L is lesser than target, then we have to return the array dot length, array dot size, else return the L index. We can return the L plus 1 as well. Okay, not target, it is array, or we have to count the int mid, that will be L plus R minus L divided by 2. It will ensure not to go beyond R and L. Now we have to check the condition. If mid, if array of mid is equals to target, or we can say that it is less than equals to target, will shrink toward left, else we are going for. If the element is lesser than particular element, just shrink from the left. Okay, mid, and else L will be mid plus 1. For 9, if element is lesser than, I have to go on right side. If element is greater than equals to the target, you should go to left side, and that's it. Upper bound will be the same, search insert position, and floor in sorted array, floor or seal. I think this would be the good option. Search in insert position, I have to search target 5. Where should I insert it? I know it, just implementation of lower bound or upper bound depending on the situation. Floor GFG practice. Floor seal, seal the floor. We have to return the floor as well as seal. Find the first occurrence of an element. Okay, these questions are pretty good. Find the occurrence of first element. Find the first occurrence of an element. If the target is not found, return the -1. First occurrence, do the lower bound. Do the lower bound. If the element is not equals to the index of that lower bound, return -1. First and last position, do the lower bound and do the upper bound. Simple. I have also solved with this lower bound and upper bound. I think I just implemented the I just implemented the solution, but it could be done with lower bound and upper bound. We can solve this first occurrence and last occurrence is quite simple. Like you have to find the target date. First occurrence, you have to find the lower bound. This is it. Last occurrence, you have to find the upper bound. This is it. Just go one left. This is it. This is the upper bound. This is the lower bound. If the element are same, upper bound and lower bound are same. If it if element is not present there means the value at lower bound will not be equal to target. ओके जो मैंने गलत किए समीशन, क्या मैंने उसमें अपर बाउंड लोअर बाउंड यूज किए थे? नहीं. एट द टाइम, okay, at the time when I was doing this, I was not aware about upper bound and lower bound. That's why I implement the binary search. Count the occurrence of number, get the first, get the last difference. Search in rotated sorted array. These questions are pretty good. These questions are good. Search in rotated sorted array. Search in rotated sorted array. Second, find minimum in rotated sorted array. And how many element in array has been rotated? Single array. Okay. These questions 1, 2, 3, 4, 5, 6, 7. These questions are good. Yeah, and you might face this question in the interviews. Okay. Search in rotated sorted array. So I have solved the daily question as well. So let's start. Two best non overlapping events. Event 0. We have got its value. Event 0 4 2 5 2 2 2 4. If the events are overlapping, then what we do? We will solve this question at night when we were solving about DP problem about 9 p.m. So we have 8 minutes. Let's not search in rotated sorted. We have to solve these floors. Let's solve this. Given a, I have submitted it. No. Given a sorted array and integer x, find the index 0 as largest element in array, so that given a sorted array and the integer x, we have a sorted array and integer x, and find the index of largest element in array that is less than or equal to x. We have to find the largest element that is less. This element is called floor of x. So that element is okay. We have to find, for example, there is a 19. We have to find it. We have to find the 19. We have to find 12. If we have 10, we have to find 8. If we have 9, we have to find 8. Okay, we have to find 8. So just we have to find the lower bound and the index before the lower bound. We have to just find the lower bound. Auto IT lower bound, and there will be an array dot begin and arr dot end comma x, and the int idx, the index will be what will be the index? it minus arr dot begin, and I'll return the idx minus 1. I think it should work. It will work. Your code output is 3. Correct output is 2. 3 3 4 5 6 6 8. The element is 4. The element 2 0 1. इक्वालिटी भी है क्या? आई डोंट नो. That is less than or equals to x. The largest element that is less than or equals to x. So we have to find the lower bound. Okay, like if array of idx is equals to x, then return idx, otherwise return idx minus 1. Okay, I'll get the, where is my test cases? Where is my test cases? Still error. 26. So we have 26 here. The lower bound of 26 is this. So 10 and 12. 0 1 2 3 4 5 6 7 8 9 10. Are you fooling me? If the multiple occurrence, last occurrence, we have to find the last occurrence. Just go with upper bound. I haven't read the question properly. Okay, and you have to return just idx minus 1. It will work. Definitely it will work. It is work. Seal the floor practice. We have to find 7. We have to find the 5 6 8 9 6 5 6. It is not sorted. We have to sort it. Expected time complexity is log order of n. What are you telling about me? Given an unsorted array of integer int and x, find the floor and ceiling of an element in x. Floor of x is the largest element which is smaller than or equal to x. Ceil of x is the smallest value. We have 6 and 8. We have 7. So I'll go for either 7 or the smallest value less than 7. If element is equal to 7, the ceil and floor will be 7 7. If we are not able to find the 7, we have to just find the element that is greater than and let us solve this. We have int ceil, that is ceil, that will be, we have to find the, it will be int min. Ceil will be the largest element, and int floor, and it will be the smallest element. Okay, so 4 int address of I in array. Okay, if I is equals to x, just return x comma x. Okay, else if okay, else if I is, this element is smaller than x, if this element is smaller than x, or else it will be larger than x. If it is smaller than x, then c will be max of c comma this I, and the floor will be min of floor comma this I. Okay, return C comma F. Okay, if C is equals to int min and F is equals to int max, return -1 comma -1, else if C is equals to int min, return -1 comma F. Order of n or order of 1. We got the problems. I am just wasting my time in this kind of song. First, last, search in rotated sorted array. Let us see how to do the search in rotated sorted array. If this is array and this is search, we have to find an element. Okay, it is quite good question because array is sorted, and array is sorted, then its structure is like this. Let me solve you. Its structure is like this. Sorted array, sorted array, sorted array, then the other value will be started from, like after here the value will be started from this, value will be less than this. So you have to find either just find the this point into order of n and do the binary search here or do the binary search here. So we have to apply the raw binary search, just keeping in mind this position. Either it will go here or here. We will solve this question tomorrow. Okay, so tomorrow our task is to complete this binary search. Okay, this will be completed like this easy question and binary search or answer. Most of the binary search of answer, these questions are brilliant questions. When the earlier time when I was solving this type of series, I have skipped this book allocation problem, and some of the problems I have skipped, so I have to do this time. And then we are going this in this, and there are two questions. There is a one question and there is a 2D matrix. These questions are great. And then in 2 days maximum I have to do this. 2 days means 4 hours. We have 4 hours to finish this binary search.